All right, so now we're going to go deeper into what a ionic bond is and some properties of ionic compounds that are formed from ionic bonding. So if you remember back in our ion video, we discussed where these charges come from. So these are your oxidation numbers or charges from the periodic table. So everything in column 1 has a +1, column 2 is a +2. We'll come back to these later, the transition metals. We've got column 3, which is going to be a +3. Mainly we'll be doing aluminum. We can kind of skip these for right now. And lead and tin, we'll discuss, they behave a little bit differently. Then we have a couple of nonmetals up here that are going to have a -3 charge because they're in the 5th column and they want to have 8 total electrons to follow that octet rule and be like a noble gas. Column 6 is those are going to pick up 2 electrons. Column 7, they're going to gain 1, and then column 8, they really don't do anything, right? So an ionic bond is a bond between a metal and a nonmetal that have exchanged electrons. So it is between a metal and a nonmetal that have exchanged electrons. Right? So remember that the metal is going to be a positive. So metal is a positively charged cation, and it's going to be attracted to a nonmetal that is a negatively charged anion. So opposites attract. So when a metal becomes positive and a nonmetal becomes negative, then they're attracted to one another. So we use the example of sodium. So sodium is in column 1, and sodium has a +1 charge. So it has given up 1 electron, and it's actually given its electron to chlorine, which has a charge of -1 because it's in column 7. And these two come together in an ionic bond, and they actually form a compound that we write like this, NaCl, meaning that there's one sodium and 1 chlorine, right? And we call that compound sodium chloride. That's where we're going to get in the next video, where we really start working on formula writing and naming of different kinds of ionic compounds. We're just starting with some of the simple ones. One of the things that I'd like for you to see is that when you have 1 sodium and 1 chlorine, yeah, sodium has a +1 charge, chloride has a -1 charge, but together their net charge is 0. So always with ionic compounds, the amount of positive and negative is going to cancel out, and the net charge of an ionic compound is going to be equal to 0. So let me give you an example of one that's not a ratio of 1 to 1, right? So if we look at calcium right here is in column 2. So calcium has a +2 charge. And then if we go over and we look at phosphorus over here, phosphorus is in this column, so it's going to have a -3 charge. So in order for these to cancel out, we're going to have a different number of things, right? So actually, we're going to have 1, 2, 3 calciums so that they all add up to a charge of +6. And then to balance that out, we have 2 phosphide ions that each have a charge of -3, so that it's a +6, so that the net charge together will be 0. And that's how we can kind of figure out what ratios they come together. And if we write the formula for that, it's 3 calciums, 2 phosphides. So we write it like that. Calcium, there's 3 of them. Phosphides, there's 2 of them. And again, we'll come back to that later, but I just wanted you to see that sometimes the ratio isn't even, right? These 3 calciums would be giving up 6 total electrons, so they would need 2 phosphoruses to gain the 6 total negative electrons so that we could balance out. Oops, sorry, this should be -6. All right, so then let's talk a little bit about what happens with the behavior and what are some of the properties of these different kinds of ionic compounds. So when those positively charged cations and negatively charged anions come together, we call them ionic compounds. that are formed by ionic bonds. Anything that is an ionic compound, we generically call a salt. So if we look back here, I've been talking a lot about sodium chloride. The common name of sodium chloride is just table salt, right? It's what you eat with your dinner. This is also a salt because it's an ionic compound. So any ionic compounds are said to be salts. And also, if you kind of remember, we called column 7 halogens because they're salt formers, because quite often these guys are going to hook up with metals and make ionic compounds, and so they're called salts. That doesn't mean that oxygen and sulfur and stuff don't form salts, but it was just sort of how they got their name. Another thing about ionic bonds or ionic compounds is they have a crystal structure which gives them some of their other properties. They're going to be solids at room temperature, as opposed to other kinds of compounds that aren't ionic, that tend to be liquids or gases. They're actually called covalent compounds. They're very brittle, so if you were to hammer them, they actually would shatter. An ionic bond is the strongest type of bond that we have. And because it is a really strong bond, it has a really high melting point, like hundreds of degrees Celsius. I have a really high melting point. The other property that ionic compounds have is that they can conduct electricity. Now, when they are solids, right, they really can't conduct electricity because, like when we talked about metals, conducting electricity is when charge can flow from one place to another. So they can conduct electricity not as solids, but in a couple other instances. If you were to melt them, so when melted, so you take a solid salt and you melt it and it can flow from one place to another, so you have charge flowing. This isn't very common because of this. It takes a huge amount of heat to melt ionic compounds, so not as practical, but we could also dissolve them in water. So when you dissolve an ionic compound in water, all of a sudden you have these charged cations and anions that can flow from one place to another, and they can conduct an electrical current. In fact, when they're dissolved in water, we call ionic compounds or electrolytes. Right. So those are some properties of ionic compounds and how they form given metals and nonmetals and the exchange of electrons. In the next unit or in the next video, we'll learn about how to write the formulas for them correctly and how to write names.